Hello, so in today's video, we're going to look at shading regions of the XY plane defined by inequality. So what we mean essentially is shading just regions of this XY plane. So for example, perhaps something like this. Well, that's not a very good sketch, but something like that, where we're going to be shading regions using inequalities. So yeah, we've got three examples here. And we'll go through each one. So starting with example one, shade the region of the xy plane where y is greater than 2x plus 1. So let's start with this one. So y is greater than 2x plus 1. So the question like this, what we want to do is actually sketch the line y equals 2x plus 1. So again, we've got our xy plane. So this is the xy plane. And okay, yeah, we're going to start sketching the actual straight line y equals 2x plus 1. And we're going to use a dotted line to do this. So yeah, y-intercept of 1, gradient of 2, so something like this. We're going to use a dotted line to do this because of this strict inequality. So when you have a strict inequality sign, like a strict greater than sign or a strict less than sign, you want to use a dotted line. So the convention is to use a dotted line. Okay, so now we want to shade the region where this inequality is true. Okay, so it's going to be this region here above the straight line. So why is that? Well, that's because when you pick any coordinate there or here or there or anywhere above this straight line, what we'll find is that the y coordinate is actually bigger than the y coordinate on this straight line. So in other words, the y coordinate is bigger than 2x plus 1. So therefore, this region above the straight line will be our defined region. So if we just shade in a region like that above the straight line, we do get our result for this problem. So the region here, just to be clear, so this region is defined by the inequality y is greater than 2x plus 1. So the key thing is that if you see a question which asks you, which gives you a region like this and says define the region, so the region will be defined by this condition here. So that's that example done, question one done. How about this one? So y is less than or equal to x squared plus 5x plus 6. Let's go to a new page for this one. So y is less than or equal to x squared plus 5x plus 6. So with this one, again, the same kind of thing. We want to actually start by sketching y equals x squared plus 5x plus 6. Now we know that we can actually factorize this here. If we just put an x in there and an x in there, factors of 6 which add up to make 5, so that's going to be 2 and 3. So we can factorize that. So if we actually sketch the graph, we're going to have a root at -3, as we can see from this factor there, and also a root at -2, as we can see from this factor there. So we get those two roots. We get a y-intercept of 6 perhaps up there. So perhaps we've got a curve that looks something like this. Obviously, it's a positive parabola because of the positive x squared coefficient. So perhaps a curve like that. Okay, so now let's shade the region of this curve or this xy axis or this xy plane where the y value is less than this x squared plus 5x plus 6 value. You've probably guessed it. It's the region below. It's the region below the curve. So this region below the curve is the region defined by this inequality, this condition here. And you'll notice that I've actually drawn in a solid black line here. The reason is for this this equal to condition that we've got in this inequality sign here. So the convention now is to draw a solid line rather than a dotted line when you have an inequality like this. So solid line because of the equal to part of the inequality sign. So again, this region here is region. So this is the region defined by y is less than or equal to x squared plus 5x plus 6. Okay, so we've done part 2. And then the next part, okay, so y is now bigger than or equal to x squared plus 7x plus 12, but less than or equal to, sorry, less than strictly, minus x squared minus 6x minus 8. Let's try this one then. So question 3, x squared plus 7x plus 12 is less than or equal to y is less than negative x squared negative 6x negative 8. So with a question like this, where you've got a double inequality, it's probably best to break it up into two different inequalities. So number one, and number 2. So if we start with condition number 1, so x squared plus 7x plus 12 is less than or equal to y. We can actually factorize this left-hand side again. So this is just x plus 3 times x plus 4 is less than or equal to y. So let's draw a sketch of the curve y equals x squared plus 7x plus 12. We know that we've got roots at -4 and -3 just by looking at our linear factors there. And we've got a y-intercept of plus 12. So perhaps y-intercept of plus 12 up there. A positive quadratic because of the 1 coefficient with the x squared. So perhaps something like this. I'll just try and fudge the graph there. So yeah, where is this less than or equal to y? Well, it's going to be everywhere where the y coordinate is bigger than our curve. And again, we're going to use a solid black line in this case rather than a dotted line because of this inequality there. So this means a solid line. Okay, yeah, so it's going to be where y is greater than this. So when y is greater than the curve. So y is greater than the curve in this region up here, above the curve. Okay, so that's going to be region number 1. How about region number 2? So this is when y is strictly less than negative x squared, negative 6x, negative 8. Okay, so with this one, obviously we've got the minus sign in front of the x squared there. Let's just factor out the minus sign. So we get minus x squared plus 6x plus 8 all inside the brackets. Just going to make the writing smaller. Okay, so now then, we can actually factorize the inside of this square bracket there. So if we do that, we get x and an x. Now, factors of 8 that add up to make 6, well, that's going to be a plus 2 and a plus 4. So y is going to be less than negative x plus 2 times x plus 4. So if we just sketch this graph, so the key thing is that we've got a negative quadratic because of the negative sign. So it's going to be an upside down shape like that. We've got roots at -2, so -2 and -4. And we've got a y-intercept at -8 there. So perhaps the curve is going to look something like this, going down like that. Yeah, so that's going to be our curve. So where is the y coordinate less than that curve? Well, it's less than that curve below the curve. So it would be this region here. What I actually should have done here, because of the strict inequality sign, was I should have done a dotted line. This is obviously a strict inequality, so we need a dotted line here. So really what I should have done is a dotted line. So obviously in the exam, make sure you do use pencil with your graphs in case you do make a mistake, but this should be a dotted line there. Okay, so now then, we want to actually, well, we've got the 2 regions, but obviously we want to solve the combined inequality. We want to sketch the region in which the total inequality is satisfied. So that's just going to be the intersection of both of those regions that we sketched. So just by looking at other graphs, if we sketch the graphs on a single XY plane, so final region. So I'll draw the sketch here. So we've got our first one, which goes like this. Sorry, I'll try and draw this better. Something like that, perhaps, with -4 there, -3 there. We've got the dotted line, which goes from -4 to -2. The roots are -4, -2. So this one here. So we've got our 2 regions. So that's obviously region 2 here as well. Sorry, that should be a 2. So where do the 2 regions intersect? So in other words, where is the y coordinate between this graph and also between this graph? Well, clearly it's going to be this middle intersection region here. So this region here would be our region. So let's just make a note of this. So this region is defined by x squared plus 7x plus 12 is less than or equal to y, which is less than -x squared, -6x, -8. So yeah, that would be the sketch of this region. So yeah, we've looked at 3 examples of sketching regions. This one there, this one we just did, and the first one with the straight line there. So yeah, you can use inequalities on the XY plane to sketch the necessary regions which are defined by such inequalities.